It's a pleasure to be here, and I'll just briefly give you a tour of some of the outer space affairs that we are working on. But actually, what I really will talk about is complex systems on Earth. Our mission, as you heard at Space Enabled, is that we seek to advance justice in Earth's complex systems using designs enabled by space. And for all those who are designers here, I hope you hear that word with significance. It also means I'm constantly asking, how do we ensure sustainability both in space and on Earth? And the argument I want to highlight is that if we don't intentionally design for sustainability, it's not guaranteed to come. Right now, as we think about this time of the pandemic and the moments of key questions and different options that we're exploring, it means we can ask, how do we design for just and liberatory futures within complex systems? And what's possible today that wasn't possible in the past, but also what's harder and what's, in a sense, more urgent than today than it was in the past. I really appreciate that we already explored the MIT land acknowledgement. So I'll just add that it was actually in my slides earlier. I took out the full text, so just to say that part of what I do when preparing for a location is, if I'm speaking somewhere else, is to check the Whose Lands website to find out whose territory I might be visiting, whether virtually or in person. So I encourage you to learn more about the different communities in Wampanoag and others that are also linked to the land on which MIT sits. The mission statement of Space Enabled also helps us drive our methodologies. And one of the key phrases you see there is complex systems. I want to give a nod to the heritage at MIT of the Engineering Systems Division and today's Institute for Data, Systems and Society, which trains people from backgrounds that include engineering, computations, social science, and policy to have tools to address the complex systems that make up our world today. That's what I'm drawing from as well. I also give a nod to the many voices at the outside of the engineering and science field, and sometimes inside, that I draw from and asking, what does it mean to advance justice? Having that, of course, is a bold statement. It means I need to draw from a lot of heritage. And this is my visual reading list. And I encourage you to create one like this for yourself to ask, who are the voices you're listening to? And here I'm highlighting particularly Black women and other women scholars, as well as activists, poets, dreamers, thinkers, actors, and makers who have helped us think differently about the definition of justice today. And I'll highlight how that's led me to a particular working definition of what it means to work towards sustainable outcomes in society. At the very bottom stage of this process is a stage drawing from increasing equity, which is basically those who currently have power, looking around to see where there are not equitable outcomes, or people from different identity groups, nations, class groups, and saying, let's erase inequity wherever we can. The next layer is to say, what were the sources of those inequity? What are the traditional sources of disequality or intersectional identities that often experience inequality or inequity, and to eliminate those sources of power and bring them into more equity across different groups. But the next steps actually require work from those who are experiencing a lack of equity or injustice currently, and they have a role to define their own self-determined vision for the future and to work toward their own liberation, which we see constantly throughout history and today. And then there's a nice phase of solidarity as people from different local organizations, different geographic locations, different nationalities and creeds start to see that their challenge and their work toward liberation and justice actually is common across geographies and across languages. And then we start to see solidarity and we can work together toward both local and global sustainability efforts that are economic, social, and environmental. And this is where the complex system part comes in, because their social systems, the economic systems, environmental relationships, they all interact in complex ways. So in order to make progress, we have to consider them as systems. This brings us to sustainable development goals that I often refer to as one of the ways to keep track of the important work we're doing as a global community on sustainability. Many of you may also adopt these. And I would say I don't take them directly, meaning they have some flaws, but they also are one of the most integrated ways of describing sustainability that our global community has developed so far and has agreed upon. And of course, what's powerful is these aren't just 17 different goals. There's 17 related systemic goals. And of course, what you do in goal number 1 links to goal number 11. And so today we'll highlight a lot around the point of view of what it means for sustainable cities and peri-urban areas around cities. And of course, that links directly to people's experience of access to jobs, education, healthcare, and other system relationships. So I want to argue before you that working on sustainable development through the SDGs or through these visions of an equitable future is about designing within complex systems where social, environmental, and economic relationships intersect. And of course, around this is issues like politics and other relationships, but we'll use those three as kind of a way to summarize those key issues. I'll give you a few examples of my own team's work in this area, and ask how are we considering a complex system design framework as a way to address opportunities to make progress, especially with those who have experienced oppression in the past. Goal number 1 links to goal number 11, their own future. A lot around the point of view of what it means for sustainable cities and peri-urban areas around cities. And of course, that links directly to people's. Sure. Is the sound still working for you guys?
Yes, you're live again.
All right, thank you. In my team in particular, since we're called Space Enabled, our goal is to use technology from space to help support sustainable development in these complex systems. In particular, I highlight 6 examples here: satellite Earth observation, satellite-based communication, satellite positioning and navigation services, space technology transfer, human spaceflight, research infrastructure, and the benefits we gain from microgravity research. Actually, as a highlight, I'll note that I'm teaching a class every spring. I just came from that class, actually, which is a class that takes each of these 6 technologies and explores in more detail what are the current policy and technology trends, how are they changing, and how are these tools currently and in the future going to be used to support sustainable development goals. Students do projects highlighting particular technology areas and matching it to an SDG and identifying what are the design opportunities. And we just came from a discussion on satellite communication and looking at the revolutions happening in that industry and how it will change access to information. In addition, our approach within Space Enabled draws from multiple ways of thinking, including design and artistic practice, as well as activities in social science and engineering, data science, and complex system modeling. So ultimately, we're asking, how can we not just think of systems as complex, but consider different ways of drawing wisdom and practice to make progress with them? I always give credit to my members of my team. So this is Space Enabled as it is today. I just want to appreciate them. You'll see some of their work throughout the discussion. I want to give them credit for the contributions they're also offering. I mentioned often that we're considering the role of satellite Earth observation as a tool for sustainable development, and I'll highlight examples around the world. I have the privilege first of studying how countries in different regions of the world are starting space activity, including in Africa, Latin America, and Asia, and then how are they using the results of satellite activity for national decision-making and policy toward development. And we can look at the global scale as well as the national scale. Just to give you a sense of scale as well, here we can highlight 2 different styles of satellites that have been used to observe the Earth. I showed an image of different constellations operated by NASA to study the Earth. And here's a traditional, large-scale, very expensive scientific satellite that has been built and operated by NASA for over 20 years called Terra. It has a friend called Aqua, another friend called Aura. And they've been some of the key science satellites that have provided really useful data for 2 decades already. Now, in contrast, what we see today is a lot of companies also offering a different style satellite. We call them literally small satellites, but they're not just smaller. They're also designed with different engineering capabilities. And these are the size of a loaf of bread, and they operate, this is a company called Planet. They take pictures of everywhere on Earth at least once a day, and they have about 200 satellites that are quite similar that are always being replaced. Instead of having 20-year life, they're looking for more like a year or 2 life. So it's a whole different engineering paradigm, but all this technology is available. Both the, what I'll call the traditional style engineering and the newer style are both playing a key role to give us information because they have different strengths and weaknesses technically. So around the world, we are interested in having results such as this one, a NASA visualization that's freely available, representing powerful data, showing what's happening in both the oceans and on land, and helping us understand how vegetation health is changing seasonally. And where you see the bright green, you're seeing the benefits of chlorophyll development. You're seeing a healthy vegetation, healthy crops, healthy forests. And that's so important to understanding the global health and thinking about climate change as well. Now, how is this happening in different countries around the world? I've had a chance to visit the leaders in countries like Kenya and others around the world, including in Mauritius, as well as Nigeria. You see a model of their first national satellite there, Nigeria Sat-1, as well as South Africa. Each of these countries in the African region, but also others, including Chile and Mexico, Argentina, Brazil. And I can think about Southeast Asia, I've been to Malaysia and Singapore and Thailand. They are actively using space technology in their national development and also at local scale. So I wanted to highlight a few examples of our team's collaboration with countries around the world to make this technology locally relevant. In particular, we'll ask the question, how do we design for sustainable coastal cities, especially when the boundary between urban and rural starts to blur? I highlight coastal cities, particularly thinking about Sustainable Development Goal number 15, which looks at biodiversity, as well as number 11, which looks at the sustainability of cities. And what we see is often biodiversity happens near coastlines where the ocean and freshwater lakes and rivers and major urban areas come together. There's a large number of key cities near the equator that are port cities, have high and increasing populations, and have also been places traditionally of biodiversity, where perhaps important forests and fish species have gathered and thrived. But of course, population pressure does influence the biodiversity opportunities. So what happens in these environments? We often use a tool called EVDT, which is a framework that our team developed. It stands for Environment, Vulnerability, Decision, Technology. We ask the question, can we bring together information from these four different types of thinking? What's happening in the environment? How are humans affected? What's happening from the point of view of policy making? And what technology is available to analyze this and to improve our knowledge about it? And so we can show you examples from Brazil, for example, how we're using this to monitor the health of mangroves in an urban environment, but what we would call a small rural island within the urban setting. So here you see our colleague Jack Reed, who is currently a doctoral student in Space Enabled, along with several hosts, including a research team that is focused in studying the activity of mangroves and the health of fishers just outside Rio de Janeiro city. And this is from the Federal University of Rio de Janeiro. In the background, you're seeing some important trees called mangroves, which are part of a series of species around the world that play a key role in enabling fisheries, especially in coastal areas near the equator. Now, it's important for us to use data from satellites to understand the health of these mangrove trees. If they're doing well, the community has many benefits, and these are often low-income communities depending on fishing for their livelihood. And so in this area, of course, it's a major city. Rio de Janeiro has been host to some major international events like the World Cup and the Olympics recently, and all of this important activity on the urban side does have pressure toward the health and survivability of these important forests right near the city. They're protected by policy, and then we were working with the city government to understand how they're using data such as from satellites to decide how to manage these trees. Ultimately, it leads to making a tool, a computer-based tool developed by my colleague Jack, that's going to combine information about the environmental changes, the socioeconomic needs, as well as the policy changes. We're working closely with an economist to have better economic models to understand how do the local communities benefit when the trees are maintained. Another example takes us to Benin, and we're now in parts of West Africa, looking at the city of Cotonou, right in the southern coast of Benin. And you're seeing the company called Greenkeeper Africa, which is an eco-technology firm, and they're focusing on remediating an invasive plant. Here's another place where the urban and the rural come together. This is a view we took from a drone, looking down at amazing houses that are based right on a lake in southern Benin in Cotonou. And this is a traditional way of living where this community has developed a very marine-oriented life where they use mainly human powerboats to get around. But just a few hundred yards from here is a thriving city. And even though sometimes people who travel this way are traveling by water, they may get stuck due to this invasive plant. And it may cause great economic harm for them and also affect their local fishing practices. Very close by is a busy city, and you see just beyond these human-powered boats, there's a major road we just came off of, and there's many other kinds of environments that are urban oriented. So it's not as though a city means you're away from nature or the environment. These things are intermingled closely. Our team's working with this company, Greenkeeper Africa, to develop a satellite-based imaging system to understand where this invasive plant is growing. They harvest it with local community members. They convert it into a product that absorbs oil pollution and sell it for commercial application. But to do that, they want to understand both how to plan where to harvest and how to account for the benefits of the harvesting and show the impact they're having on the community. So ultimately, we're creating data like this that basically shows there is a story highlighting that there's actually been an increase in the amount of the water hyacinth over time. You're seeing a 20-year history here based on long-term free satellite data from NASA. And this major line over the red line, basically the red line is the average. And the fact that the black line is so much higher means that we have seen overall an increase in this long time period, and showing that there's actually an increase due to human behavior in the activities of the plant. But this is a boring graph. So ultimately what we want is a very user-friendly design-oriented tool. This will be an interactive tool that'll be freely available online, having data from satellites, as well as water-based sensors, showing how the chemistry of the water affects the growth of the plant as well. Let's go to one more location. Now we're in Ghana, where I've been hosted by the Ghana Space Science and Technology Institute, as well as the Ghana Statistical Service. Both government agencies are interested in a concern about what's happening with mining of gold in Ghana. Now, Ghana is blessed with many beneficial areas where gold is available, and there's an EPA system, Environmental Protection Agency, at the national level providing guidance on how to do mining safely and with environmental concerns. There's also been an uptick in mining that does not follow legal requirements, and there's also a tradition of small-scale mining done at the household level called galamsey. And so the government asked us to work with them on using satellite data to monitor where there's been an increase in mining. And where you're seeing in this orange line are the numbers of hectares or acres that are deforested due to mining over multiple years. And you're seeing an increase, especially in the years 2013 to 2016. And you can ask the question, is this an urban problem or perhaps a rural problem? And in fact, it's both, because something we were able to measure was areas that were converted from forest or vegetation into mines, where you see this major change near a river, especially, where you see a lot of pollution brought in by the mining. We also found areas that were converted from deforestation into urban areas. So the pink in this picture highlights areas that were deforested, but they transitioned into an urban setting. So again, the change in deforestation, whether it's an economic activity like mining, or whether it's a growth of an urban area, they're happening very close to each other. And the policies that regulate both must be interrelated. And so we see this idea of the blurring between the urban and the non-urban, because they are certainly a part of a larger system. Now let's consider COVID. How has our team responded with these same tools? We found that our tool, the EVDT model, could be expanded to consider public health. So we call this VIDA, drawing from the Spanish word for life. So our VIDA decision support system is very similar. It still has environment, vulnerability, decision, and technology. We started to collaborate with a colleague from Harvard School of Public Health and added a public health dynamics model. So we can start to consider what's happening in the environment also given COVID. This has led to a chance to collaborate with 5 countries, including Mexico, Chile, Angola, Brazil, and Indonesia. We identified particular urban areas, key centers that are high population centers, and we worked with either local city level government or national level government teams or academics who are giving advice on the response to COVID in those countries. We built on existing relationships with people we already knew. And in fact, I had been invited to visit Chile in March 2020, and I was supposed to go there and talk to the government. And instead of doing that visit, we instead started working together on this project virtually, since I actually could not go. I'd also been invited to Indonesia also during 2020. Again, the trip was canceled, but we had a chance to start collaborating. And due to that, we're able to bring together local data and publicly available data about what's happening when governments put in place restrictions on movement due to COVID. Do we see a change in personal activities like mobility? And do we see a change in the cases? So we've been tracking these 5 countries, at least one city in each country, over the last few years. And it's so examples, highlighting, for example, the change in the number of cases. This is from Indonesia, and the change in policy. So you see, for example, when the policy goes down, that means it's becoming more tight, more strict, and there should be less mobility. But sometimes mobility actually does not follow that, and you see the mobility actually going up kind of even faster than the policies are going up. But also the case numbers were unfortunately continuing to rise in these first 150 days of the pandemic. Looking at Chile, for example, you see where they had actually very tight restrictions and they were done at a very granular level. This is looking at the capital city of Santiago in Chile. You see the policies, when it's lower lines, it means very tighter social distancing policies, and the higher lines means gradually relaxing. Once again, we see that mobility patterns tend to sort of jump up ahead even as the policy starts to gradually relax. But here the cases actually did go down due to the strict policies. Let's take one more look at what it means to advance justice. It also means considering how technology, complex systems, and issues like anti-racism come together. I want to appreciate work I'm doing with Dr. Caitlin Turner. She comes from a background in nuclear science and engineering, and we are considering in our fields of nuclear technology and of space, what does it mean to apply actively concepts like anti-racism into the design of these complex systems? I refer you to a wonderful essay she's written on the topic with further understanding of the historical context of her field and mine. I've also written about this from the point of view of space, asking what does it mean to actually bring this concept of being anti-racist, being focused on gender equity, and considering different points of view from different identity groups as we do our design in complex systems. It includes, for example, also considering the indigenous point of view on space exploration. And so I wrote on previously called Columbus Day, now called Indigenous Peoples Day at MIT. I wrote an essay highlighting the need to be anti-colonial in our thinking because we could easily repeat some of the mistakes from the past as we go forward in space. All of this comes together, and it's not just working to apply technology where it's needed, but to make sure that our values while doing it are right and they're drawing from an approach that can be integrated into our engineering process. I'll just close with this. Inspiring is to say we're in an exciting time where cities, especially coastal cities near the equator, are going to play a key role in what it means for our world to survive as the climate continues to change. And we have a chance to use data from space and other tools from complex systems and other engineering tools, but they must be designed with a cleverness that draws from many practices, including artistic practice, as well as design from other fields, as well as social science. So we can do this in a way that advances justice. Thank you so much.